RNNs work on sequences of data. The recurrent memory cell is unrolled as many times as there are input instances in our data set. Now, when we are working with reviews, every word is an input instance. How do we ensure that all reviews are of the same size so that the sequence length is the same across all reviews in our data set? The sequence length has to be the same because it has to correspond to the number of layers in an RNN. In this demo, we'll see how we can use recurrent neural networks that we'll set up using TensorFlow for text classification. We've already seen that text is sequential data, which means they're well suited for recurrent neural networks. The original of the code that you're going to see in this demo is available on this GitHub page that is displayed on screen. I've made some major changes though, mostly to simplify the code. The RNN that we'll set up will use the long short term memory cell as well. The problem that we'll solve here is a sentiment analysis problem where we'll classify movie reviews from the Rotten Tomatoes database as positive or negative. If you want to access this dataset and download it onto your local machine, you can do so from this site at cs.cornell.edu. You'll download a tar gzipped file, the RT polarity data file. And once you unzip and untar it, you'll get two files, the rtpolarity.neg and the rtpolarity.pos. The .neg file contains all the negative reviews and the .pos file contains all the positive reviews. You've already seen in previous demos how you can automate the download of such files and make sure that the file is present in your current working directory. In this demo, though, I'm going to simply use the files that I already have set up in this working directory where my code lives. I'm not going to show you how to download it from this URL. If you want to automate the entire process, you can simply add in the download code, deal with the peculiarities of this particular tard and gzipped file, and extract the .pos and .neg files and store it in your current working directory. At this point, I'm going to assume that the files are present and ready for me to use. I'll set up a few helper functions first. The getReviews helper function reads in the file from the specified path and extract the reviews and the corresponding labels, either positive or negative. The first input argument to this helper function is the path to the file, and the second is whether it's the positive review file or the negative review file that we are currently reading. For the Rotten Tomato reviews dataset, all the positive reviews are present in one file and the negative reviews in a different file. A label to indicate a positive review is equal to 1 and the negative review has the label 0. Use the built-in Python libraries to open the file in read mode and then read in the reviews. Every review is present in a separate line. So f.readlines will simply give us a list of reviews. All of the reviews that we just read in are either positive or negative based on the input argument that we pass to this helper function. Set up the labels accordingly. Every review is now associated with a corresponding label. Return the text reviews and the associated labels. I'll now use a different helper function called extract labels data, which will call the get reviews helper and basically put together all the positive and the negative reviews and their associated labels. I've mentioned this earlier, but here is a heads up once again that this code assumes that the files rtpolarity.pos and rtpolarity.neg have already been downloaded from the URL that you can see up there and are in the current working directory. The files have been untarred and unzipped, and these positive and negative review files are what we have in the current working directory. Call the getReviews helper function on rtpolarity.pos and get the positive reviews and the positive labels. The labels are 1 for positive reviews. We pass in the path to the file, it's in the current working directory. That's why we just use this relative path, and we set positive equal to true, indicating we're reading the positive review file. Do the same thing for the negative reviews. Call get reviews, pass in the negative review file, set positive equal to false. Now put this data together. All the reviews are in the data variable and all the labels are in the labels variable. Call this helper function and store the labels and the data. When you explore this data, the first thing that you should note is that the reviews are not shuffled. All the positive reviews are at the beginning and the negative reviews at the very end. This is something you need to take care of before you feed in this data to our machine learning model. Here is a sample of a few of the positive reviews. The Rotten Tomatoes reviews dataset has a total of 10,662 reviews and, of course, corresponding labels. Half of these are positive and half of these are negative. Now, these reviews are going to be fed into an RNN after we found numeric representations for every word in the review. We'll come to that in a little bit. But before that, when we feed these reviews into an RNN, we feed them in as a sequence of words. RNNs work very well with sequences. Reviews are words following one another in a certain natural order. So that's a sequence right there for you. Now, the question when it comes down to a recurrent neural network is how long will a sequence be? Because the length of the sequence determines the depth of our recurrent neural network. It determines the number of layers our RNN will have. This is something that we need to determine. To that end, we find the maximum length of a review, that is, the maximum number of words that one review can contain. And this turns out to be 61. Remember that in a text sequence, we will feed in one element for every time instance. That means we'll feed into the RNN one word at every time instant. And here is where you have to make a decision. Every review needs to have the same length, that is the same number of words, because that is the number of layers our neural network will have. This number of words per review is something that you need to figure out, and this is our maximum sequence length. In the real world, when you make this choice of the maximum sequence length, there is a trade off that you have to consider. You want it to be long enough so that it captures the essence of most of the reviews, and short enough so that you don't have too many reviews which are much shorter than the sequence length, because those reviews will have to be padded. In order to make sure that all reviews are of the same length, reviews which are shorter than 50 words will be padded, and reviews which are longer than 50 words will be truncated to be of length 50. We've chosen the number 50 here because most of the reviews are under 50 words. This way, we are only losing the information in a few of the longer reviews which are beyond 50 words. This is a parameter that you can tweak and see how the results of your machine learning model changes. And this is the point where we start the process of setting up numeric representations for our words. This process starts with identifying the complete vocabulary of our datasets. The vocabulary is a set of all words that are present in our training data, that is the reviews dataset. Remember that the vocabulary is a set of words. That means if a word appears more than once in our training dataset, it should appear just exactly once in the vocabulary. The next step is to represent every word in our vocabulary using a unique identifier. So the first word that we encounter will have an identifier of 1, and the last word in our vocabulary will have the identifier equal to the size of the vocabulary. Just to note that this identifier is not the word embedding, it is one step in the process to generating a word embedding. Once we have unique numeric identifiers for each word, every review can be expressed in terms of those unique identifiers. Every review is a vector of unique identifiers. This is not the worst restaurant in the metropolis, not by a long way, can be represented entirely using these numbers. The word not has a unique ID of 3, so wherever we encounter not in our review, we use the identifier 3 to represent it. Once we have every review expressed in terms of identifiers, we'll use the training process of our RNN to generate embeddings for every word. Each word is encoded into vectors of the same dimensionality. In our sentiment analysis example, the process of training our RNN generates the word embeddings as well using our review dataset. Instead of generating our own word embeddings as a part of our neural network training process, we can also get embeddings which have been pre encoded. We can use embeddings that have been generated using a model such as the word to vec or glove, and use the pre-trained word embeddings for sentiment analysis. We are not doing that in this particular demo. In this demo, we generate our own word embeddings. We ensure that all reviews are of the same length by specifying a maximum sequence length. We choose this maximum sequence length so that the majority of the reviews fall within this word length. If there are reviews which are shorter than this word length, they're simply padded. And for reviews which are longer, the words at the very end are truncated. Padding and truncation is how we ensure that all reviews have the same number of words. This is a requirement before we feed in review data to our RNN.